Hello Year 1, here's your feedback for Thursday's lesson. First of all, we're going to scroll down so you can mark your own work for your first worksheet. Starts off nice and straightforward because all these would have one of their 4 sections coloured in. Here are some different examples of finding a quarter. I wish they'd used a ruler on these, it would have been more straightforward to be able to see what the answers were. This is an interesting one. It's been cut in half this way. So this half and this half are the same. If they've cut that bit's in quarters, but this one, the other rectangle, has been cut acrossways, but it's still a quarter. They've done halve it and halve it again, just a slightly different way. For this one, actually this shape is in quarters because it's got 4 equal pieces. This is why it would be a no, because one of them does show quarters. And these are our 2 shapes that show quarters. Although this half here hasn't been cut into quarters, this is still 1 out of what could be 4 pieces. But this one's got 5 and only 1 coloured in. And this one, it would have needed that extra triangle to be a quarter. And here's our next activity. So to cut any of these into quarters, then we'd need 2 pieces. So it could have been this piece and this piece. It could have even been this one and this one. So any way of showing quarters, so it had to be 2 of the sections coloured in, but any combination of those would be correct. Here's our next problem. We had to say who we'd agree with and why. So one of the people says that they think 2 quarters are shaded and the other person thinks it's 1 quarter. So I'm going to show you here that this, let me just lock this in place. I'll make that easier. If we were to move that blue square to here, we can see that's the same size. So if that was to move to here, that makes a full quarter. So because that piece is like a missing bit that's been taken from 1 quarter, it is correct that a quarter is shaded. For it to be 2 quarters, it needs to be the whole of this square and the whole of this square, or any 2 from the shape. Last, here are our missing number problems. So if we think about the strategy we've used of finding out what the first bit's worth, that is equal to 9. Then we need to think 3 plus something also needs to be equal to 9. So our answer would be 6. And the second one, 3 and 8 are the same as 11. Total the same as 11. So that means to make this the same, we need to make this 10 add 1. And last of all, 5 subtract 4 would leave us with 1. 2 take away 1 would also give 1. So they now balance, they're both worth the same. Now for these, we need to think about what all the possibilities are. So I'm going to borrow this and put it on a new screen. So for questions where you have to find all possibilities, think about what the smallest number could be. So here, if that was, I'm going to copy this actually so we can see all the different ones. So we can see the same calculation lots of times. I don't know how many there are going to be at the moment because I need to work it out. So the smallest number that could be here is 0. And 4 plus something needs to equal 12. So if I was going to have 4 add 6, that would make 10. 4 add 8 would make 12. I could also do 12 take away 1. So that now makes 11. So 4 plus 7 would make 11. I can predict there might be a pattern going down here. So let's this time take away 2. This has to be 6. And let's carry on with our pattern. So I'm going to keep putting some numbers in here because I can see a pattern is emerging. So as this number gets smaller, the other number gets bigger. Let's check that definitely works. 4 add 5 is 9. 12 take away 3 is 9. 4 add 4 is 8. 12 take away 4 is 8. 4 add 3 is 7. 12 take away 5. So take away 2 to get to 10. Take away another 3 to get to 7. So we can keep going down. Oh, and here, so we've got 4 plus 0, and then this was going to be 8. So the smallest number I could make at this side was 4. So this is all the possibilities that I would be able to make, because we can't make this side, not in year 1 anyway, with our knowledge of positive numbers and negative numbers. So these are the possibilities that we would be able to make, and we can see this nice pattern. And don't worry if you didn't find all of them, as long as you could have a go and find lots of different ways and understand that there were different numbers that could go in there. That is super for year 1. And here's our next question. So this one has one of the crocodile signs. It shows 3 plus 4 is greater than 12 take away something. So we know this makes 7. So this one has to be bigger and this one has to be less. So again, let's see some values. So we could try a number and see what works. If I made that 2, we can think, is that correct? That makes 7, that makes 10. It's not correct. The crocodile has got to eat the biggest number. So if this is 7 at this side, I have to make this be a smaller number. So a number smaller than 7, I could make 6. 12 take away 6 would be 6. And you could think here, if I need to make this number smaller, I need to be choosing bigger numbers to go here. So this would also be true. 3 and 4 is 7, which is bigger than 12 take away 7, which would be 5. And we can keep going again. Choose some different numbers. Let's see what we've got here. So the answer for this one, 12 take away 6 was 6. 12 take away 7 was 5. 12 take away 8, that is going to be 4. 12 take away 9 is going to be 3. And we could keep going up all the way until we get 12 take away 12 would be 0. 3 and 4 is definitely, 3 plus 4 is definitely bigger than 0. So that means we'd also have these possibilities in between 12 minus 10 and 12 minus 11 to make that correct.